Hey, welcome back to Math with Patrick. Today is the last day in January, and we're solving the 31st problem from this Daily Epsilon calendar. All right, let's try it out. X is equal to the cardinality, or the size, of the set of numbers that are square-free integers from 101 to 150. Okay, so a set is just a collection of numbers, like kind of like a list, but I don't really care what order they're in. So it's kind of just like a collection. And then these vertical bars here tell me to find the cardinality, or essentially just a fancy word for the size of the set. So I'm going to count up all of the numbers in my set, and I should have 31 of them because that's today's date. And we're supposed to find square-free integers from 101 to 105. An integer is just a whole number. Well, an integer could be negative, but since we're between 101 and 150, have I been saying 105 this whole time? Since we're between 101 and 150, these integers are just going to be whole numbers, are going to be positive. And finally, a number that's square-free is one that can't be divided by a square number. So for example, like 100 is not square-free because I could divide it by 25. I could also divide it by 4. So it's kind of like doubly not square-free. All prime numbers are going to be square-free. That's just because I can't really divide them anything besides 1 or itself. So there's no way that a squared number could be down there. But there are some other numbers that are composite. How about 6? That are still considered to be square-free. Because sure, I can divide it by 2, or I could divide it by 3, but I can't divide it by any square numbers. Well, I could, but I'd get a non-whole number, or I'd get a remainder. And that's just considered to be not... No, it is considered to be square-free when I can't divide it into a whole number of parts by a square number. So I could do this maybe a naive way and just inspect every single number, like starting at 101. I'd have to try dividing it by all the square numbers that I know that kind of like build up to it. So I'd have to try 4, and then 9, and then 16, and then 25. I don't really want to do it that way because then I'll have to try 50 different numbers, and I'll have to try, well, I'm not sure exactly how many different or square numbers I need to divide these by. It just seems like a lot of work if I go one by one. So instead, I want to do like a math strategy that's called a sieve, where I'm going to list out all my numbers in an array, or just kind of like a list. And I'm going to go like one by my square numbers. So I'll do 4 first, then I'll do 9, then I'll do 16, and so on. And I'll cross off some numbers in my array that are not square-free, or in other words, ones that are multiples of these square numbers. And I'm hoping that by doing it that way with a sieve, it's just a little bit faster and there's like less computation for me to do instead of trying number by number and proving it one by one. So I'm going to take some time and write out that list. Well, here are all my numbers from 101 to 150. And I said I would cross off all the ones that are multiples of 4. And, well, an easy place to start would have been 100. I know that was a multiple of 4. I already talked about that. But I guess maybe the next one would be 104. So if I take 104 and divide by 4, I will get a whole number. That would be, what, 26? And that shows me that it's not square-free. Maybe it's square-full. I don't know the word for that. Maybe I'll call it square-full. Why not? Sounds like the opposite of square-free. And what I can do here is just count up by 4, and I'll find my next number that's square-full, not square-free. Not really sure which one I should pick. But I can just keep going. 1, 2, 3, 4. 112 is not square-free. 1, 2, 3, 4. And I'll just keep going up. And it's kind of making a nice pattern here where I can just kind of see that I'm like skipping each of these rows. Like I'm going skip, skip, skipping. It's just kind of counting up by 4s, but the way that I wrote out my list gives a nice visual pattern to all of my multiples of 4. And the next one would be 152, but that's outside of my array, so I'm all done. I have found all numbers that could be divisible by 4. well, let's pick another number. And now I need to do the square of 3, which is 9. I would pick like 90 or 99. So then 108 would be my next number that is divisible by 9. But I already picked it. It's already there. So I guess I should count it by 9 and then find the other ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. 117. And then also just kind of the way that I made this array, I can see kind of a visual pattern going on. 108, I would have crossed off. Why not? I'll just do both. I'll cross it off with the green just to show that it's also divisible by 9. And it looks like counting up by my 9s, I'll just go in this pattern, going down to the left. And that gets rid of all numbers divisible by 3 squared. Now the next square number is 16. That would be 4 squared. But I think I already covered it, because if a number is divisible by 4, then it's no. If a number is divisible by 16, then surely it's divisible by 4. So I've already crossed off all of my 16s in here, so I don't really have to try or to look for them. Though, why not? I already kind of doubled up on these, the 4s and the 9s, so I guess I'll find the 16s. Why not? Let's see, 160 would be a really easy number to figure out, so I guess I could subtract 16 from that. That would be 144. So wow, this 144 is super not square free. Then I'll subtract by 16, so that would be minus 10, then 1, 2, 3, 4, 5, 6. So there we go. It's another multiple of 4. No surprise there. Then minus 10, 1, 2, 3, 4, 5, 6. Got it. And then if I take 112 and subtract it by 16, I will be below 101. So I just kind of doubled up or even tripled up on that number. Didn't really have to cross those off, but I figured why not? Okay, let me pick a different color, and I'll do 25, and I'll keep going. 100, and then 125, and then 150 are all going to be divisible by 25s. Pretty easy to count by 25s. I'm thinking of like adding quarters together. And then maybe I need another color for the 36. Let's see, what's an easy number to start on? I don't know, maybe I'll just count up by my 36s at this point. 36, 72, 108. Okay, I already got that one. And then 8 plus 32 gives me 144. Okay, and I already got that one. Wow, okay. Do I need to check my 7th? I guess I should. I probably need to. Let's see, another color that I haven't used. 7 times 7 is 49. And counting up on my 49s, I go 49, 98, and then 147. So that knocks off just the 1. 8 times 8 is 64. And then kind of for the same reason, I don't really need to check divisibility by 64 because checking the 4 down here already covered it. And then 9 times 9 is 81. I don't really need to check that either because the 9 already covered it. And then 10 times 10 is 100. Don't really need to cover that because the 2 already dealt, or the 2 squared equals 4, already kind of dealt with that. And let's see, 11 squared is 121. Ooh, and I do think I need to consider this one. So I'm glad I kept searching because this one actually does matter. I'm running out of colors here. 121, that is 11 squared. And so 121 is not square free. Okay, that was a lot of searching. Maybe I'm done. I'm going to give myself some time to think. So I kind of already realized that trying some numbers like 36 or 64 were redundant, like some of the previous ones already took care of them. And I just realized that it's the prime numbers squared that I should really be checking. So 2, 3, not 4, 5, not 6, 7, not 8, 9, or 10, and 11. Like those were the important ones to check the multiples of. And so the next prime number after 11 is going to be 13. And I know that 13 times 13 is 169. And there's no way that I'm going to find a multiple of 169 because it's greater than 150. So this number right here tells me that I'm fine to stop. I don't need to check divisibility anymore because this number's too big. And at this point, I have already crossed off all of my square full numbers. And now it's time to just count up all of my square free ones. Well, let's just count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Got it. So we have 31 square free numbers between 101 and 150, and that matches today's date. Cool. Well, we're all done. That's the whole video. Thanks for coming along, and I'll see you in the next month. All right. Bye.